over the next 25 years, the world will experience changes that most people have not yet considered. Recent 2025 projections indicate that we are approaching a period where milestones like NASA's Artemis lunar habitat could move from concept to reality, and breakthroughs in quantum computing and climate technology will become part of daily life. Economic growth is expected to outpace population increases, driven by technological advances and renewed investment in infrastructure. This documentary presents the most thoroughly researched events likely to shape our civilization by 2050. We will examine each development with careful attention to what is plausible, highlighting the ways these changes may redefine our place beyond Earth. Space exploration milestones. Among the most significant developments on the horizon are the milestones in space exploration that will shape the coming decades. NASA's Artemis missions, beginning in 2026, will send astronauts back to the moon with the aim of establishing a sustainable presence. While initial landings and short-duration outposts are expected in the late 2020s, extended crew rotations and a fully operational lunar base are projected for after 2028. These early Artemis outposts will serve as proving grounds for new technologies, such as advanced life support systems and improved radiation shielding, that are vital for longer missions deeper into the solar system. SpaceX, meanwhile, is advancing its Starship program with the goal of reaching Mars. Uncrewed test flights to Mars could occur as early as 2026, but most analysts expect the first crewed Starship mission to take place in the early 2030s, provided critical milestones like orbital refueling and safe landings are achieved by 2029. The first human expeditions to Mars would likely involve brief surface stays of about a month, with longer rotations and more permanent infrastructure following as experience and resources increase. The company's ambitions include developing a self-sustaining colony, with future missions gradually extending human presence on the Martian surface. China is also making major strides in space. The Tiangong space station, which will be fully operational in the early 2020s, is set to expand by 2030 with additional modules, including international science laboratories. This facility may eventually serve as a docking hub for deep space missions. China's long-term plans involve a crewed lunar mission in the 2030s and continued investment in research infrastructure beyond low Earth orbit. Private companies are expected to play a larger role in orbital operations. Commercial space stations, such as Blue Origin's orbital reef and modules from Axiom Space, are on track to begin hosting crews before 2030. These stations will offer platforms for research, manufacturing, and tourism, supporting 4 to 8 people at a time. Industry estimates suggest private visitors may pay hundreds of thousands of dollars per night in the early years, reflecting the exclusivity of space tourism. The Lunar Gateway, an international project, will act as a transfer point for lunar missions starting in 2028 and will inform deep space transit techniques needed for eventual Mars expeditions. Scientific missions will return valuable samples from other worlds. NASA and ESA aim to bring Martian soil back to Earth by the early 2030s, which could provide evidence of past or present life. The Europa Clipper mission, targeting Jupiter's icy moon in the mid-2030s, may analyze plumes for chemical signatures of biology. These efforts will help scientists answer fundamental questions about life beyond Earth. Propulsion technology is poised for major advances as well. NASA's work on nuclear thermal propulsion could see ground tests by 2035, potentially leading to flight demonstrations later in the decade. Such engines would reduce the Earth-Mars transit time to under 100 days, decreasing astronaut exposure to radiation and lowering mission costs. Other experimental systems, like plasma and fusion drives, remain in earlier research stages and are not expected to see operational use before 2050. As commercial activity expands, legal frameworks for space resources are under review. The Outer Space Treaty currently prohibits national claims to celestial bodies, but does not fully address the realities of asteroid, mining, or lunar resource extraction. New policies are under discussion in the next decade to clarify property rights and profit sharing as private companies begin prospecting beyond Earth. By 2045, Permanent research bases on the Moon and Mars could support rotating crews of scientists and engineers. On Mars, initial habitats will likely be buried under regolith for radiation protection, supporting small teams on 18-month rotations. Lunar outposts may grow to accommodate up to 20 people, with pressurized modules linked by tunnels. These bases will enable research in materials science, astrobiology, and technology development. Under partial gravity, space-based solar power may also become a reality by 2050. Demonstration satellites are expected to test wireless power transmission by 2040, and full-scale arrays could beam energy to Earth with increasing efficiency. Japan and China are leading these efforts, with test satellites planned for the 2030s. While these milestones represent dramatic progress in exploring and utilizing space, another revolution is unfolding in how we observe the universe itself. Revolutionary telescopes and cosmic discoveries. New generations of telescopes will soon transform what we know about the cosmos. The Giant Magellan Telescope, scheduled for completion in 2029, will use 7 massive mirrors to achieve significantly higher resolution, roughly an order of magnitude improvement over Hubble. Its adaptive optic system will allow astronomers to directly image exoplanets around nearby stars, searching for water vapor and weather patterns in their atmospheres. The GMT will also give researchers a close look at galactic cores, helping to clarify the behavior of supermassive black holes and the environment around them. China's Xiuquan Space Telescope launched in 2021, with operations starting in 2024. It matches Hubble's optical quality, but offers a field of view 350 times larger, allowing wide-area surveys of star-forming regions, the distribution of dark matter, and transient cosmic events. Positioned in low Earth orbit near China's space station, Xiuquan will be periodically serviced and upgraded, ensuring it remains at the forefront of astronomical research for years. NASA's Habitable World Observatory, planned for the early 2040s, will focus on the search for life beyond Earth. This telescope will operate across ultraviolet, visible, and near-infrared wavelengths, targeting the chemical fingerprints of water, oxygen, methane, and organic molecules in the atmospheres of distant exoplanets. Its primary mission is to study dozens of potentially habitable worlds, with the goal of characterizing at least 100 Earth-like planets by the mid-2040s. The observatory's findings will help determine how common the conditions for life might be across the galaxy. The Square Kilometer Array, expected to begin operations in 2028, will mark a major leap in radio astronomy. By combining thousands of antennas across Australia and South Africa, the SKA will map the distribution of cosmic hydrogen with sensitivity far beyond current instruments. This will reveal the large-scale structure of the universe and trace the formation of galaxies back to the universe's first billion years. The SKA will also help detect faint radio signals from the earliest galaxies and probe the cosmic web that connects them. New advances in interferometry will further increase the detail astronomers can observe. By linking telescopes across vast distances, even between Earth and lunar orbit, these systems could achieve resolutions equivalent to a telescope the size of the Earth-Moon distance by the mid-2030s. This would allow surface features on nearby exoplanets to be resolved and provide detailed images of black hole accretion disks. Other branches of astronomy will see similar breakthroughs. Next-generation neutrino detectors, such as IceCube Gen 2 under Antarctic ice, aim to pinpoint the sources of ultra-high-energy cosmic rays by 2035. These sources might include active galactic nuclei, gamma-ray bursts, or supernova remnants. Meanwhile, dark matter research will advance with the deployment of 5-kiloton xenon detectors in the 2040s. These underground experiments seek to detect rare collision events with weakly interacting massive particles, pushing the limits of background noise reduction to unprecedented levels. Gravitational wave astronomy will become routine by 2040 as new detectors track thousands of black hole mergers each year. Combining gravitational wave data with electromagnetic signals will provide new insights into how stars evolve and how galaxies form and change over time. the search for extraterrestrial life will intensify as these telescopes analyze exoplanet atmospheres for biosignatures. The GMT and Habitable Worlds Observatory will examine promising targets such as the TRAPPIST-1 planets for evidence of oxygen, methane, or other chemical markers that could signal life. Statistical analysis across hundreds of surveyed worlds may reveal how common life is in the universe, even if no single planet provides definitive proof. Researchers will also refine methods to distinguish genuine biosignatures from naturally occurring processes, improving our understanding of what counts as evidence for life. As our view of the universe sharpens, similar technological leaps will drive progress in addressing challenges much closer to home. Climate technology breakthroughs. Climate technology is poised for a period of rapid progress as nations accelerate efforts to decarbonize energy, industry, and infrastructure. The coming years will see a series of breakthroughs and large-scale deployments that reshape how societies manage emissions and resource needs. Fusion energy is one of the most anticipated advances. The International Thermonuclear Experimental Reactor, ITER, will achieve its first plasma in 2025, with full deuterium-tritium operations targeted for the mid-2030s. If successful, ITER will demonstrate the potential for net energy gain from fusion. Private companies are also pursuing compact tokamak reactors, aiming for pilot plants by 2035 that could supply electricity directly to power grids. These reactors use powerful superconducting magnets to confine plasma at extreme temperatures, offering the promise of baseload power without long-lived radioactive waste. Direct air capture DAC will expand from its current pilot phase, where plants capture tens of thousands of tons of CO2 annually, to industrial-scale operations. Companies like Climeworks are developing next-generation DAC facilities that reduce energy use per ton captured. By 2040, the combined capacity of global DAC projects could reach 1 gigaton of CO2 removed per year. Captured carbon will be permanently stored through mineralization or used in new materials and fuels. U.S. policy, including expanded tax credits under the Inflation Reduction Act, is expected to lower DAC costs and make large-scale deployment viable within the next decade. Artificial photosynthesis, which mimics the way plants convert sunlight, water, and CO2 into energy-rich molecules, is expected to reach commercial viability by 2035. Early prototypes already achieve around 10% efficiency in laboratory settings. Once scaled, these systems could produce carbon-neutral fuels and chemicals without relying on agricultural land. The European Union is investing in demonstration plants to bring production costs in line with fossil fuels. Renewable energy will continue to dominate new electricity generation. Solar photovoltaic PV capacity is projected to triple by 2035 as new cell technologies achieve over 30% efficiency. This expansion will be supported by grid-scale energy storage, including flow batteries using iron-based electrolytes and compressed air storage in repurposed mines, which may reach cost targets of $100 per kilowatt-hour by 2035. These systems will help stabilize power supplies as more intermittent renewables come online. Small modular nuclear reactors, SMRs, are set to complement renewables with reliable, low-carbon baseload power. The first U.S. SMR license is expected in 2027, with commercial operation following by 2030. These reactors use standardized designs and passive safety features, reducing construction timelines and costs compared to traditional nuclear plants. Carbon-negative materials are also gaining traction. Studies predict that by 2040, up to 50% of new concrete may incorporate CO2 mineralization, permanently locking captured carbon into building materials and reducing emissions from cement production. Companies such as Solidia and CarbonCure are already piloting these technologies, and mycelium-based composites are emerging as alternatives for non-load-bearing structures. Urban agriculture is changing food supply chains. Vertical farms using stacked hydroponic systems and LED lighting are delivering new supplies of leafy greens in major cities. These facilities use 95% less water than conventional agriculture and achieve much higher yields per square foot. Countries like Japan and Singapore are operating profitable vertical farms with low energy costs, and the model is expected to expand as urban populations grow. Innovation is not limited to energy and food. Bioengineered crops designed to sequester more carbon in soils will begin field trials in the early 2030s. These plants, combined with regenerative farming practices, could remove significant amounts of CO2 from the atmosphere while improving soil health and supporting food security. Early estimates suggest these approaches could offset a substantial portion of agricultural emissions by the mid-2040s. Geoengineering research is advancing with caution. Experiments such as stratospheric aerosol injection will be closely monitored, and international governance frameworks are under development to address risks and set reporting standards for climate intervention technologies. Government support remains a driving force. Incentives like the U.S. Inflation Reduction Act and the EU's Carbon Border Adjustment Mechanism are shaping investment decisions, encouraging industries to adopt cleaner technologies and reduce emissions. The climate tech sector is experiencing rapid growth, with investments targeting hard-to-abate industries and strategic supply chains for critical minerals and manufacturing. These climate technology breakthroughs are laying the foundation for a new era of sustainable development. As solutions scale up, attention is turning to the ambitious infrastructure projects that will redefine how people live and work in the decades ahead. Megaprojects reshaping civilizations. Across the globe, a new generation of megaprojects is taking shape, each designed to address the pressing challenges of urbanization, resource management, and environmental sustainability on an unprecedented scale. These large-scale initiatives reflect both the ambition and complexity of modern engineering and planning. NEOM, a planned smart city in Saudi Arabia, stands out as a central element of the country's Vision 2030 plan to diversify its economy. Covering 10,000 square miles, NEOM will eventually include several cities and developments, such as The Line, a 2.4-kilometer linear urban corridor, and Oxagon, an industrial hub on the Red Sea. The city's infrastructure will be powered by renewables, solar, wind, and green hydrogen, while artificial intelligence and the Internet of Things will manage urban systems, from energy and water to transportation and logistics. Modular construction and robotics will be used to assemble buildings efficiently, reducing waste and construction times. NEOM's approach to city planning, with a focus on zero carbon living and integrated smart technologies, is attracting international investment and influencing urban design worldwide. In Europe, the Grand Paris Express is reshaping public transportation for the Paris metropolitan region. This project, launched in 2020, will add 200 kilometers of automated metro lines and 68 new stations by 2030, forming a ring around the city and connecting outlying communities. The use of driverless trains and advanced control systems aims to reduce congestion, improve access to jobs and services, and foster economic growth in suburban areas. Green construction practices, such as the use of recycled materials and energy-efficient station designs, are integral to the project's sustainability goals. The Grand Paris Express is regarded as a model for future urban transit networks, balancing efficiency with environmental concerns. China's South-North Water Transfer Project is among the world's most ambitious infrastructure efforts, designed to address chronic water shortages in northern China. By diverting water from the Yangtze River through thousands of kilometers of tunnels and canals, the project aims to supply over 100 million people and support agriculture and industry in arid regions. Advanced engineering solutions are required to navigate diverse terrain and minimize environmental disruption. The project scale has resulted in significant costs and the relocation of communities, but it remains vital for the country's long-term water security. Libya's Great Man-Made River Project is another example of large-scale water infrastructure. Drawing on deep aquifers beneath the Sahara, the system uses an extensive network of underground pipes to deliver water to northern cities and agricultural regions. The project provides a critical resource in one of the world's driest environments, supporting millions of people and helping stabilize food production. Renewable energy megaprojects are also transforming regional power supplies. India's Dallara solar power plant, for instance, covers 11 square kilometers and produces up to 700 megawatts of electricity using a mix of fixed and tracking solar panels. Centralized inverter systems convert the generated power for grid use, supporting the country's goal of expanding clean energy capacity and reducing reliance on fossil fuels. Urban adaptation to changing environmental conditions is prompting new forms of construction. Floating city prototypes in Southeast Asia and the Pacific are being developed to address rising sea levels. These projects, such as the Busan Floating City in South Korea, use interconnected platforms made of buoyant materials, with solar-powered desalination and waste-to-energy systems providing essential services. Designs are tested for resilience against storms and typhoons, with the goal of creating viable communities on the water. As these megaprojects advance, they set new standards for how societies manage growth, resources, and environmental risks. Their success depends not only on engineering, but also on the ability to integrate new technologies and adapt to evolving needs. In the coming decades, the systems and infrastructure built today will intersect with emerging digital tools and decision-making frameworks, shaping how cities and nations respond to rapid change. The AI revolution, artificial intelligence, is set to become one of the defining forces shaping the next several decades. Expert surveys suggest artificial general intelligence, or AGI, could arrive sometime between 2040 and 2060, though forecasts vary widely. The rapid progress of large language models has led some entrepreneurs to predict AGI as early as 2030. This acceleration is closely tied to the ongoing growth in computing power, which continues to double roughly every 18 months. If traditional hardware reaches its limits, quantum computing may provide the necessary leap to reach human-level machine intelligence. AI's impact on drug discovery is already visible and will deepen by 2035. Algorithms can now analyze vast chemical libraries and predict how molecules will interact, allowing researchers to identify promising compounds in days rather than months. Pharmaceutical companies are investing heavily in AI platforms that integrate genomic and chemical data, targeting diseases that were previously considered untreatable. By the mid-2030s, it's expected that AI will contribute to half of all new pharmaceutical developments, reducing the cost and time required to bring treatments to market and improving clinical trial success rates. Neural interfaces are another area where AI will play a central role. Research teams are developing both non-invasive sensors and implantable devices that translate brain signals into digital commands. Early systems are focused on restoring basic movement for people with paralysis and treating neurological disorders. By 2040, more advanced interfaces could enable users to control devices with their thoughts or access enhanced cognitive functions. As these technologies mature, security and privacy concerns will require new safety standards and oversight. The labor market will undergo significant changes as automation and AI become more capable. Estimates suggest that 20 to 30% of current jobs could be automated by 2040, particularly in roles involving routine or repetitive tasks. At the same time, entirely new job categories will emerge, focused on managing, auditing, and collaborating with AI systems. In some jurisdictions, AI judges may handle routine legal cases by 2035, streamlining processes for contract disputes and traffic violations. Examples from Singapore and Estonia show early adoption of AI-assisted legal tools for small claims. Workforce retraining programs will be essential to help workers adapt to the changing landscape and develop skills that complement machine intelligence, especially in areas requiring creativity or emotional understanding. Quantum AI is expected to solve optimization problems that are out of reach for classical computers, with practical applications anticipated by 2040. Financial institutions plan to use quantum-enhanced algorithms for risk modeling and portfolio management, while logistics companies look to optimize global supply chains and reduce costs. In material science, quantum simulations could reveal new superconductors or battery materials by modeling atomic interactions in ways not possible with current technology. AI's contributions to scientific research will continue to grow. By 2038, it's plausible that an AI system could be credited with a Nobel Prize-worthy discovery, combining data analysis and theoretical modeling to uncover new principles in physics or chemistry. Already, machine learning tools play a role in a significant portion of published research, and future systems may autonomously design experiments or propose novel hypotheses. Debate continues over what counts as true intelligence. Some researchers argue that the term AGI is too broad, proposing advanced machine intelligence to describe systems that match or exceed human abilities in certain domains without replicating the full range of human thought. Experts like Jan LeCun point out that human intelligence includes social, emotional, and existential dimensions that current AI does not capture. AI will also drive innovation in climate technology, material science, and biotechnology. Machine learning helps identify alternatives to traditional plastics and optimize their production, a critical need as plastics threaten to consume a large share of the remaining emissions budget. In agriculture, AI supports the development of crops that sequester more carbon while maintaining productivity. These advances will be crucial for meeting climate goals and supporting sustainable development. As AI systems become more capable, governance and oversight will become increasingly important. The European Union's Artificial Intelligence Act, expected around 2025, will likely set standards for risk management and transparency. Other countries are developing their own frameworks, balancing innovation with safety and ethical considerations. By 2050, human-AI collaboration is expected to be the norm across many fields, with professionals relying on AI for analysis, design, and decision-making. The integration of AI into daily life and work will set the stage for further advances in human capabilities, as emerging technologies in medicine and biotechnology begin to reshape what is human augmentation for health and biotechnology and human performance. Over the next few decades, human augmentation and biotechnology will see steady advances, fundamentally altering how people treat disease, recover from injury, and enhance physical and cognitive abilities. By 2035, CRISPR 3.0 is expected to become a standard tool for correcting hereditary diseases at the genetic level. This next-generation gene editing system offers greater accuracy and fewer unintended changes than earlier methods. Initial applications focus on blood disorders such as sickle cell anemia, but researchers are developing targeted delivery techniques that could expand treatment to a range of genetic conditions. Lab-grown organs are projected to reach commercial availability by 2030. These organs, cultivated from a patient's own stem cells, have the potential to eliminate transplant waiting lists and reduce the risk of rejection. Early successes include the growth of functional miniature livers from induced pluripotent stem cells, and the first clinical use cases will likely involve simpler organs, like bladders, before moving on to more complex organs, such as kidneys and hearts. This development could transform transplant medicine and provide new options for patients with organ failure. By 2040, human trials may begin for nanobots designed for targeted drug delivery. These microscopic machines are engineered to travel through the bloodstream and deliver medication directly to affected tissues, such as tumors. Prototypes are being tested for their ability to identify disease markers and release drugs at precise locations, which could improve the effectiveness of treatments and minimize side effects. Some research is also exploring the use of magnetic fields to guide these particles to specific sites in the body. Anti-aging therapies are under development with the goal of extending healthy lifespans by as much as 30 years by 2050. Approaches include drugs that clear out senescent cells, therapies that activate telomerase to maintain chromosome stability, and gene therapies that mimic protective variants found in long-lived individuals. Several companies are planning human trials for these interventions, and early animal studies have shown promising results in delaying age-related decline. Brain-computer interfaces are expected to restore mobility for paralyzed patients by 2030. These systems connect the brain to external devices, translating neural activity into commands for robotic limbs or computers. Current versions allow users to control prosthetics with reasonable accuracy and new implants are being developed to improve signal quality and reduce invasiveness. Research is also underway to provide sensory feedback, allowing users to experience touch and movement through artificial limbs. Exoskeletons are set to become common in industrial settings by 2035, enabling workers to lift heavy objects with reduced risk of injury. These wearable devices use sensors and actuators to augment strength and endurance, and next-generation models will incorporate artificial intelligence to anticipate and support user movements. The technology is also being adapted for military use, where exosuits can increase a soldier's load-carrying capacity and endurance. Gene drives may be deployed by 2030 to control populations of disease-carrying insects, such as mosquitoes that transmit malaria. By spreading genetic modifications that reduce fertility or block disease transmission, these interventions could sharply lower the incidence of malaria and other vector-borne diseases. Field trials have shown significant reductions in mosquito populations, and regulatory frameworks are being developed to manage ecological risks. Synthetic biology is expected to play a growing role in environmental remediation by 2040. Scientists are engineering microorganisms that can break down pollutants, absorb heavy metals, or degrade plastics. These organisms offer a biological solution to cleaning up contaminated environments and are being designed with safety features to prevent uncontrolled proliferation outside of intended areas. Personalized medicine based on multiomics data is anticipated to become standard by 2050. By integrating information from genomics, proteomics, and metabolomics, doctors will be able to tailor treatments to each individual's unique biology. Hospitals are building bioinformatics capabilities to process and interpret this data, with AI systems assisting in identifying optimal therapies. This approach is already being used in oncology for selecting cancer treatments and is expected to expand to other fields. As these technologies mature, they will require new ethical frameworks and regulatory oversight to ensure safety and equitable access. The convergence of biotechnology, AI, and medicine will not only transform healthcare, but will also influence how societies adapt to broader challenges in the coming years. Energy transformation. Energy systems worldwide are entering a period of rapid transformation, marked by the accelerated adoption of renewables, new storage solutions, and the growing importance of energy independence. Over the next decade, solar photovoltaic capacity is expected to triple, driven by advances in perovskite cell technology. These next-generation panels are projected to reach 40% efficiency, capturing more sunlight than traditional silicon cells and lowering production costs. As manufacturing scales, solar power will become the most cost-effective electricity source in many regions, making it a primary driver of the shift away from fossil fuels. Offshore wind energy is also set to play a major role, with floating platforms and larger turbines unlocking new locations and providing more consistent output. By 2040, offshore wind farms could supply 10% of global electricity, supported by expanded port infrastructure and specialized installation vessels. Countries such as the UK and China are investing heavily in these projects, aiming to meet growing demand while reducing emissions. Green hydrogen will become increasingly important for decarbonizing sectors that are difficult to electrify, such as heavy industry and shipping. Electrolyzers powered by renewable energy will produce hydrogen at a scale large enough to support steel mills, chemical plants, and cargo vessels. New policies, including tax credits and direct investment, are making green hydrogen competitive with fossil-derived alternatives. Early deployments are already underway in Europe and Asia, with further expansion expected through the 2030s. Next-generation geothermal energy is gaining traction as a reliable source of baseload power. Enhanced drilling techniques and closed-loop systems allow for clean energy production in a wider range of locations, not just traditional geothermal hotspots. Modular geothermal plants are being developed for faster deployment and lower upfront costs, and ongoing research aims to further reduce drilling expenses. This technology is expected to help stabilize grids as renewable penetration increases. Electricity grids are evolving to accommodate these changes. Vehicle-to-grid technology will allow electric vehicles to feed power back into the grid, balancing supply and demand as more intermittent renewables come online. By 2030, bidirectional charging is projected to become standard in many markets, with millions of EVs acting as distributed energy assets. This integration will help manage fluctuations in generation and support overall grid reliability. Energy storage is another critical component of the transition. While lithium-ion batteries remain central for short-term storage, alternatives such as flow batteries, compressed air storage, and hydrogen storage are being developed to provide backup power over longer durations. These technologies will help address the variability of wind and solar, ensuring that electricity remains available even during periods of low generation. The push for energy independence and security is shaping government policy and corporate investment. Nations are racing to secure supply chains for critical minerals, batteries, and clean energy manufacturing. The global climate tech market is projected to grow rapidly, with significant funding directed towards scaling up renewables, storage, and supporting infrastructure. By 2050, projections suggest that 90% of global electricity could come from renewable sources if current trends continue. Achieving this will require not only the continued deployment of solar, wind, and geothermal, but also investments in grid modernization, storage, and workforce development. The remaining fossil fuel generation is likely to serve as backup, with most electricity coming from cleaner sources. As energy systems evolve, the technologies and infrastructure supporting them will influence other sectors as well. These changes are already beginning to affect how people and goods move, setting the stage for significant developments in transportation. Transportation revolution. The transportation revolution is set to redefine how vehicles, goods, and people move across cities and continents. By 2035, electric vehicles are projected to make up 70% of new car sales worldwide. This shift is supported by declining battery costs, advances in solid-state technology, and the expansion of charging networks. Solid-state batteries are expected to enter mass production by 2028, offering ranges beyond 500 miles per charge and improved safety. Major automakers are preparing to phase out internal combustion engines, and many governments are using incentives and stricter emissions standards to accelerate this transition. These changes are expected to significantly reduce transportation-related carbon emissions and reshape the automotive industry. In the logistics sector, autonomous trucks are on track to dominate long-haul freight by 2035. Current pilot programs in regions like the southwestern United States show that self-driving trucks can lower fuel consumption and operate with fewer interruptions. As the technology matures, these vehicles will be able to run nearly around the clock, reducing delivery times and labor costs. During the transition, human operators may supervise multiple vehicles remotely, ensuring safety and reliability as fleets shift toward full autonomy. Urban transportation will also see major changes. By 2040, urban air mobility networks using electric vertical takeoff and landing, eVTOL, aircraft could carry 10% of city commuters. Early routes will likely connect airports to city centers, cutting travel times and easing congestion. Companies are already testing certified eVTOL designs, and cities are planning for vertiports on rooftops and repurposed helipads. Safety requirements will include redundant propulsion and autonomous flight controls, enabling reliable operations even in emergencies. High-speed ground transport is advancing as well. Vacuum tube systems, sometimes called transonic vacuum tubes, may enable ground travel at speeds up to 1,000 kilometers per hour by 2045. Prototypes are being developed that use magnetic levitation and low-pressure environments to minimize friction and energy use. Countries like China are testing reduced-scale systems, and underground routes are under consideration for connecting major city clusters. Technical challenges remain, especially regarding tube maintenance and emergency procedures, but the potential for rapid intercity travel is drawing significant investment. Aviation will undergo a significant transformation through the adoption of hydrogen-powered aircraft. By 2035, Regional flights using hydrogen propulsion are expected to be commercially viable. Aircraft manufacturers and startups are already conducting test flights with hydrogen electric and modified turbofan engines. Hydrogen's energy density makes it a practical solution for routes under 1,000 miles, and new infrastructure for hydrogen production and refueling will be needed at smaller airports. Suborbital cargo delivery could become feasible by 2040, allowing high-value shipments to reach any point on the planet in under an hour. Early applications will likely focus on urgent medical supplies and critical components, with companies exploring reusable launch platforms for rapid point-to-point transport. While costs and insurance remain barriers, advances in reusable rocketry and payload integration are pushing this technology closer to reality. Smart infrastructure is expected to play a key role in supporting these new modes of transport. Roads equipped with wireless charging will keep electric vehicles powered while in motion, reducing range anxiety and supporting autonomous fleets. Vehicle-to-grid integration will allow electric vehicles to help balance electricity demand, and dedicated lanes for autonomous freight convoys could further improve efficiency. Real-time data from road sensors will enhance traffic management and safety. Micromobility options, such as e-bikes and scooters, are projected to account for half of all urban trips under 5 kilometers by 2030. Cities are expanding bike lanes and regulating shared mobility services, while next-generation vehicles offer rapid battery swaps and improved safety features. These options provide flexible, low-emission alternatives for short journeys, helping to reduce congestion and emissions in dense urban areas. The cumulative effect of these innovations is expected to have the transportation sector's carbon emissions by 2050. Continued investment in sustainable fuels, high-speed rail, and infrastructure adaptation will be necessary to overcome challenges related to resource supply and equitable access. As transportation networks evolve, the resulting shifts in mobility patterns and infrastructure will intersect with broader social and economic changes, setting the stage for new dynamics on the global stage. Geopolitical shifts. Geopolitical shifts are expected to redefine the balance of power, economic influence, and sources of conflict by 2050. Africa's population will reach about 2.5 billion, doubling its current size and making it a central force in global markets. This demographic expansion will create a large, youthful workforce and a rapidly growing consumer base. Countries such as Nigeria, projected to overtake the United States in population, will shape new trade patterns and investment flows. However, realizing a demographic dividend will depend on whether education and job creation keep pace with the needs of these younger populations. The Arctic is emerging as a new area of competition as melting sea ice opens shipping lanes and exposes untapped resources. The Northern Sea Route along Russia's coastline could cut transit times between Asia and Europe, attracting interest from multiple nations. Russia, Canada, the United States, and others are expanding their presence and infrastructure in the region, asserting territorial claims, and increasing military patrols. The race to control Arctic oil, gas, and mineral deposits is intensifying, with legal disputes over maritime boundaries and the rights to undersea resources likely to increase as ice cover continues to recede. In space, the possibility of mining asteroids for valuable materials is becoming more realistic as technology advances. Companies and governments are developing the capability to extract water and metals from near-Earth objects, raising questions about ownership and governance. The current Outer Space Treaty does not clearly address resource rights, leaving room for disputes as commercial activity grows. The potential value of asteroid mining could reach trillions, making it a significant factor in future geopolitical calculations and possibly prompting updates to international space law. Cyber capabilities are set to become as strategically important as nuclear arsenals by the mid-2030s. Dozens of countries now possess offensive cyber programs with the ability to disrupt power grids, financial systems, and communications networks. The threat of large-scale cyber attacks, capable of causing economic and social disruption, has led to the development of cyber deterrence doctrines and the integration of digital defense into national security strategies. Incidents like the SolarWinds breach have shown how cyber operations can remain hidden for extended periods, complicating response and attribution. The global economic center of gravity will continue shifting toward Asia. By 2050, China and India are expected to account for a significant share of global GDP, with Southeast Asia emerging as a major manufacturing hub. China's Belt and Road Initiative is fostering new trade corridors, while India's economic growth is set to surpass Japan's and could rival the United States. This rebalancing will alter investment flows, supply chains, and the structure of international financial institutions. Climate-driven migration will become a major challenge, with up to 200 million people potentially displaced by 2050 due to rising sea levels, drought, and extreme weather. Countries in low-lying regions and those facing desertification will see large populations move internally and across borders. The resulting pressures on resources, infrastructure, and social systems will require new policies and international cooperation to manage the humanitarian and security implications. The European Union is likely to expand its membership to include Ukraine and the Western Balkans by 2035. Such enlargement will shift the balance within the bloc, increase agricultural capacity, and bring new political dynamics. While this could enhance stability and integration in Eastern Europe, it may also present governance challenges and require adjustments to EU decision-making structures. Technology standards and data governance will drive the formation of new economic alliances. Competing models, such as China's state-driven approach, Europe's privacy-focused regulations, and the U.S. model led by private tech firms, may fragment the digital landscape into separate blocks. Nations will align their laws and infrastructure with preferred partners, influencing trade, security, and technological development. The world order is expected to become more multipolar, with no single nation holding dominance in all spheres. Regional powers like Brazil, Indonesia, and Turkey will play larger roles, while traditional alliances adapt to new realities, including hybrid threats that blend cyber, economic, and information warfare. Institutions such as the UN and WTO may face calls for reform to better reflect the distribution of influence in the 21st century. As energy systems move away from fossil fuels, countries with reserves of critical minerals like lithium and cobalt will gain new strategic importance. Former petrostates will need to diversify their economies, and energy security will increasingly depend on access to battery materials and advanced manufacturing capabilities. Artificial intelligence will become a central component of national power, with leadership in AI research and deployment shaping economic and military competitiveness. The lack of clear governance for AI in military contexts poses risks of instability and arms races in autonomous systems. These interconnected trends will require new approaches to international cooperation, governance, and conflict prevention. As societies adapt to these changes, the global stage will also reflect shifting priorities and values through the major events and cultural milestones that mark each era. Sporting events and cultural milestones. Sporting events and cultural milestones in the coming decades will reflect both the ambitions and the concerns of a changing world. The Olympic Games, in particular, will serve as a showcase for evolving values and technological progress. Brisbane will host the 2032 Summer Olympics, marking Australia's first time as host since Sydney in 2000. Organizers plan to emphasize climate-positive infrastructure, with venues powered by renewable energy and advanced water recycling systems in place. Athlete villages are designed for conversion to sustainable housing after the Games, and the schedule, set during Brisbane's mild winter, will help reduce heat-related risks for athletes and spectators. These efforts align with a broader movement among event organizers to prioritize environmental responsibility and legacy planning. The 2028 Summer Olympics in Los Angeles will see the return of baseball and softball, as well as the introduction of sports like flag football and cricket. Organizers plan to reuse many existing venues, including the LA Memorial Coliseum, aiming for a technologically advanced games that integrates augmented reality enhancements for spectators. The city will also host the Paralympic Games for the first time, expanding the reach and visibility of adaptive sports. Meanwhile, the 2026 Winter Olympics will take place across several locations in Italy, including Milan and Cortina d'Ampezzo, using a decentralized model to reduce infrastructure costs and highlight regional sporting cultures. Looking ahead, the 2030 Winter Olympics will be held in the French Alps, with Nice expected to serve as the main host city. This will make France the first country to host both the Summer and Winter Games within a 6-year span. Salt Lake City is set to host the 2034 Winter Olympics, following its previous experience in 2002, with a focus on sustainable operations and leveraging existing venues. The International Olympic Committee continues to evolve its host selection process, allowing for more flexible timing and multi-city bids, with an eye towards sustainability and reduced construction waste. Major international football tournaments will also adapt to changing circumstances. FIFA's plan to expand the World Cup to 48 teams by 2030 will require additional host nations and new stadium infrastructure. The expanded format, tested in the 2026 tournament across the US, Canada, and Mexico, is expected to boost global viewership, though it raises questions about maintaining competitive quality. Esports are likely to become a fixture at major sporting events by the early 2030s. The International Olympic Committee has recognized the growing popularity of competitive gaming, especially among younger audiences. Titles such as League of Legends and Dota may second appear as medal events, alongside emerging digital sports like robotic soccer. Hosting these competitions will demand new types of venues equipped for simultaneous live and virtual broadcasts. Cultural heritage projects will continue to gain attention. Restoration efforts at sites like Notre Dame Cathedral in Paris are on track for completion by 2030, combining traditional craftsmanship with modern safety systems. Similar projects are planned for other landmarks threatened by climate change or over-tourism. By mid-century, the boundaries between physical and digital participation in events will become less distinct. Hybrid competitions may allow remote athletes to compete via robotic avatars, while augmented reality technology will let fans view events from multiple perspectives. Blockchain-based ticketing and personalized streaming options will become more common, offering secure transactions and tailored viewing experiences. Venue designs will focus on modularity and flexibility, supporting a variety of event types and audience sizes. As these trends unfold, sporting and cultural gatherings will increasingly incorporate digital tools and platforms. This integration will not only shape how people experience major events, but will also influence the ways society interacts, communicates, and shares information in daily life. Materials science breakthroughs. Materials science is entering a period of rapid advancement, with several breakthroughs expected to reshape industries by mid-century. One of the most significant changes will come from the commercial-scale production of graphene by 2030. Manufacturers are developing methods to produce large, high-purity graphene sheets at costs that make them viable for widespread use. Electronics companies are already preparing to launch batteries with graphene-based electrodes, which could charge several times faster than current lithium-ion cells. In construction, graphene-reinforced concrete is being tested for its ability to double strength while reducing material use, offering longer-lasting and more sustainable infrastructure. Self-healing materials are another area poised for major impact. By 2035, these materials could cut infrastructure maintenance costs in half. Engineers are incorporating microcapsules filled with healing agents into concrete and asphalt, allowing cracks to seal automatically when damage occurs. Some designs use vascular networks within polymers to deliver repair compounds to affected areas, mimicking the way biological systems heal themselves. Early applications in bridges and roadways are already showing promise, with bacteria-based concretes that seal cracks by producing limestone. These technologies extend the service life of infrastructure and reduce the frequency of costly repairs. Metamaterials are advancing rapidly, with practical invisibility cloaks anticipated by 2035. These engineered materials manipulate light in ways not found in nature, allowing objects to be hidden from view at specific wavelengths. Current prototypes are small and limited to certain frequencies, but ongoing research is expanding their range and scalability. Potential uses include coatings that help aircraft evade radar, medical imaging devices that let surgeons see through tissues, and consumer products like glare-free windows. The development of CO2-derived materials is expected to address both environmental and industrial challenges by 2035. Companies are scaling up processes that convert captured carbon dioxide into building materials and plastics. This approach not only sequesters greenhouse gases, but also provides alternatives to petroleum-based products. Carbon-negative concrete, for example, locks CO2 into aggregates, turning construction into a method of long-term carbon storage. These materials are being tested for use in packaging, textiles, and everyday goods. By 2040, 4D printed materials will begin to appear in commercial products. Unlike traditional materials, these can change shape or properties in response to environmental triggers such as temperature or moisture. Applications include self-deploying flood barriers, building facades that adjust ventilation automatically, and medical implants that adapt to changes inside the body. These adaptive materials reduce the need for mechanical parts and enable new types of responsive systems. Biological materials are also gaining ground. Advances in biofabrication allow for the production of fibers stronger than Kevlar using yeast-grown spider silk proteins. Bacterial cellulose offers lightweight and durable alternatives to leather and plastics, while mycelium-based packaging replaces polystyrene with compostable options. These innovations require less energy to produce and are designed to break down naturally, reducing environmental impact. Graphene oxide membranes are showing potential for water desalination, offering flow rates much higher than traditional filters. Large-scale production could make clean water more accessible and affordable, particularly in regions facing scarcity. Pilot plants are already demonstrating the viability of these membranes for processing significant volumes of water daily. As research continues, the most advanced materials will combine properties such as strength, conductivity, and self-repair in single substances. Hybrid composites, like those blending graphene with ceramics, enable lighter and more resilient products for aerospace and energy applications. The use of machine learning accelerates the discovery of new compounds, with algorithms predicting which combinations will yield the most promising results. Safety and regulatory oversight remain important as these new materials enter widespread use. Nanoparticles and other novel substances require thorough testing to ensure they do not pose risks to human health or the environment. Manufacturing facilities are adapting to handle the demands of advanced materials, investing in specialized equipment and clean spaces to maintain quality. With these developments, the capabilities of materials science are set to influence many sectors, from construction and transportation to consumer goods and environmental management. The impact of these breakthroughs will be felt not only in industry, but also in the systems that support health and well-being. Global health advances. A series of global health advances will reshape medicine and public health by mid-century, introducing new standards for prevention, diagnosis, and treatment. One of the most notable developments is the pursuit of a universal flu vaccine. Unlike current seasonal vaccines, these next-generation shots target conserved viral proteins, aiming to provide protection against a broad range of influenza strains. Clinical trials have demonstrated multi-year immunity, and approval of the first universal flu vaccine could arrive by 2030. If these vaccines meet expectations, they may eliminate the need for yearly reformulation and prevent hundreds of thousands of deaths worldwide each year by 2035. Artificial intelligence is poised to change cancer detection by 2030. AI algorithms trained on vast medical imaging datasets are now able to identify tumors at the earliest stages, often before symptoms appear. These systems analyze CT scans and MRIs with accuracy surpassing most human clinicians, and routine use of whole-body MRI screening for high-risk groups is expected within the decade. Early detection will likely improve survival rates across many cancer types, shifting treatment toward less invasive and more successful interventions. Nanomedicine is advancing rapidly, with engineered nanoparticles offering targeted drug delivery for conditions that previously resisted conventional therapies. Gold and polymer-based nanoparticles can deliver chemotherapy directly to tumors, sparing healthy tissue and reducing side effects. Trials are also exploring the use of nanomaterials for clearing arterial blockages and repairing nerve damage. While production costs remain high, ongoing research may soon make these treatments more accessible. And by 2040, nanomedicine could offer cures for diseases once considered untreatable. Efforts to prevent future pandemics are accelerating as well. By 2028, global early warning systems will integrate data from wastewater, animal populations, and travel patterns, using AI to flag emerging outbreaks before they spread. The World Health Organization and national agencies are building surveillance networks that analyze hundreds of signals daily. Early detection and rapid response could reduce the mortality and economic impact of pandemics, allowing authorities to act before new diseases become widespread. The field of organ transplantation may be transformed by 3D bioprinting. Researchers have already implanted printed skin and corneas in early trials, and advances in vascularization are bringing the printing of complex organs, such as kidneys and livers, closer to reality. By 2035, 3D printed organs could become widely available, reducing or even eliminating transplant waiting lists and lowering the risk of rejection through the use of patient-specific cells. Gene therapy continues to progress, particularly for monogenic disorders. CRISPR and other gene editing tools are being refined to correct mutations responsible for diseases like sickle cell anemia and cystic fibrosis. Improved delivery methods target affected tissues with greater precision, and by 2040, gene therapy may offer lasting cures for thousands of single-gene conditions. Clinical trials are expanding to include neurological and muscular disorders, raising hopes for effective treatments where few options previously existed. The human microbiome is gaining recognition as a key factor in chronic disease. Treatments that engineer or restore healthy bacterial communities, such as targeted probiotics and fecal microbiota transplants, are already successful for some infections. By 2035, microbiome-based therapies could become standard for preventing and managing conditions like obesity, diabetes, and inflammatory bowel disease. Regular microbiome screenings may become part of routine healthcare, enabling more personalized approaches to disease prevention. Mental health monitoring is also evolving, with wearable devices tracking physiological indicators such as heart rate variability and sleep patterns. By 2030, These tools will be able to identify risk factors for depression and anxiety, allowing clinicians to intervene earlier and tailor treatments more precisely. Privacy protocols will be a priority as remote mental health monitoring becomes more common. Advances in regenerative medicine, anti-aging therapies, and disease prevention are expected to extend healthy life expectancy by up to 15 years globally by 2050. Senolytic drugs that remove age cells, stem cell therapies for tissue repair, and personalized cancer vaccines are among the interventions moving from trials to clinical use. Portable diagnostic devices, implantable drug delivery systems, and AI-assisted robotic surgery will make high-quality care more accessible, especially in underserved regions. These developments will require careful management of costs, equitable access, and ethical considerations. As health systems adapt to these new capabilities, the ripple effects will be felt across societies, influencing how people work, plan for the future, and participate in economic life. Economic and financial evolution. Economic and financial systems are on the cusp of significant change, influenced by technological innovation, shifting labor patterns, and new forms of value creation. Central bank digital currencies are expected to become standard in many major economies by 2035, replacing much of the physical cash in circulation. China's digital yuan is already undergoing large-scale pilot programs, and the European Central Bank is preparing for a digital euro. The United States continues to evaluate options for a digital dollar. These digital currencies promise faster transactions and lower costs for both governments and consumers, but they also introduce questions about privacy, security, and the potential for increased state oversight of everyday financial activity. Regulatory frameworks will need to address these concerns as adoption expands. Artificial intelligence is poised to transform investment management within the next 2 decades. By 2040, AI-managed funds are projected to control a majority of assets in global financial markets. These systems will draw on massive real-time datasets, including satellite imagery and social media trends, to identify opportunities and manage risk. The speed and analytical power of AI could improve returns and market efficiency. However, the dominance of automated trading raises the risk of sudden volatility and algorithm-driven market swings. Regulators and industry leaders will have to balance innovation with safeguards to ensure stability and fairness. The structure of work itself is shifting as the gig economy grows. By 2035, flexible and platform-based work could represent a substantial share of employment in developed countries. Digital platforms are expanding beyond transportation and delivery, connecting workers to healthcare, education, and professional services. While this shift offers more autonomy for individuals, it also challenges traditional models of job security, benefits, and labor rights. Policymakers are considering portable benefits that follow workers across platforms and new regulations to protect gig workers from exploitation. The evolution of the gig economy will require careful attention to both worker protections and the adaptability of social safety nets. Universal basic income is gaining traction as a potential response to job displacement from automation. Pilot programs are expanding, with countries and regions experimenting with different models and payment levels. Early results indicate improvements in well-being and financial security, but large-scale adoption would demand significant public resources and careful design to avoid negative impacts on labor participation. As automation continues to reshape employment, debates over UBI and other forms of income support are likely to intensify. New investment opportunities are emerging through tokenization, which allows fractional ownership of assets like real estate and art via blockchain technology. By 2035, tokenized assets could be widely accessible, enabling more people to invest in markets that were previously out of reach. This democratization of investment will depend on clear regulations to protect investors and ensure the integrity of digital asset markets. To address the effects of automation, some governments are considering taxes on automated processes or the profits of highly automated companies. The revenue from these automation taxes could support retraining programs and social welfare initiatives. While intended to cushion the impact of job losses, Such policies must be carefully crafted to avoid stifling innovation or raising costs for consumers. Wealth generated by technology and new industries is likely to concentrate among a small number of individuals and firms. Predictions suggest the first trillionaire could emerge by the early 2040s, most likely from ventures in artificial intelligence or space. This level of wealth concentration will likely fuel ongoing debate about taxation, redistribution, and the broader responsibilities of those who benefit most from economic transformation. Despite demographic challenges, global GDP is forecast to double by 2050, driven by productivity gains and technological advances. Growth will be strongest in emerging markets, especially where young populations and urbanization create new demand and opportunities. Much of the value in future economies will come from intangible assets, such as intellectual property, data, and software, rather than traditional goods and infrastructure. Decentralized finance platforms are expected to take on a greater share of banking and financial services, using smart contracts to facilitate lending, trading, and insurance without intermediaries. As these systems mature, they will compete with both traditional banks and central bank digital currencies, prompting further regulatory evolution. Economic growth, however, will not automatically resolve issues of inequality or social cohesion. Without new policies, the gap between the wealthiest and the rest of society may widen. The direction of economic and financial evolution will depend on how governments, industries, and communities respond to these emerging challenges and opportunities, setting the stage for the next era of global transformation. Looking ahead from 2025 to 2050, the scale and speed of change will touch nearly every aspect of daily life. Advances in space exploration, sustainable energy, and healthcare are set to become defining features of this era. Yet the realization of these changes depends on ongoing choices about investment, research, and international collaboration. Large projects like NEOM City and the Brenner Base Tunnel illustrate both the ambition and complexity of what lies ahead. At the same time, significant funding gaps, such as the $3.7 trillion needed for U.S. infrastructure, highlight the challenges that remain. The direction and impact of these developments will be shaped by decisions made in the next decade. While forecasts provide a framework, unexpected discoveries and setbacks are likely. Adaptability and informed engagement will be essential as societies work to ensure that progress benefits as many people as possible.